A little technical difficulty, and so I worked the question out, and I'm going to reveal it right now, slowly, in order of what you should be thinking about. So question 4, inverse cosine. There's a triangle. You have the information in the sentence about the triangle, but no triangle is drawn in the problem. It's up to you to bring that triangle into a geometric drawing. Well, start by drawing JKL on your paper. In fact, I'll do it right now. I'm going to do this totally freehand. This is the worst way to do it possible. Now we got to put the letters, but we don't know where. At first when I started this, didn't know where the letters were supposed to go. So I looked at the information of angle J is 90 degrees. Then I looked at how KL was supposed to be 8. If J is here, then KL has to be the opposite side length. And so I'm going to put a 90-degree box in the corner. And then JL, I don't know, is a measure of which of these was the smaller side. And I figured L could go there. K would then have to go there. And that means our setup for our triangle is complete. So here's what I have. I've put my triangle drawing. I've labeled, and then I brought in highlight. Remember, we've been highlighting, or I've been trying to consistently highlight in the same way so that the hypotenuse has always been identified in the same fashion, in the same format. And then the adjacent side is orange, because cosine is the adjacent side divided by the hypotenuse. Well, if you don't know the angle, you use inverse to find that angle measure. And so I'm recommending we use inverse cosine like this, with the calculator in order to figure out the degree measurement of angle L. And I notice when I'm all said and done, it's done and dusted. I did not write 51.32 degrees back in the diagram. You should do that. Cosine inverse. Why don't you try question 5, and I'll show you what I did for question 5, and this video will be done, and it'll be short, and you'll be able to say you've learned about how inverse cosine tells you the angle measure. Okay, try number 5, the cable bridge problem. Okay, you're still here, so let's go. A typical cable bridge is a continuous girder with one or more towers erected above piers in the middle of the span. From these towers, cables stretch down diagonally to both sides, and they support the girder. One cable is 95 feet, and the span on the deck of the bridge from that cable to the girder is 80 feet. Calculate the cable formed by the deck and the cable. So highlighting hypotenuse, green, and adjacent side orange, boom, boom, and referencing the angle, we're able to construct a cosine ratio. Cosine of x is the adjacent side divided by the hypotenuse. But because we don't know the angle x, we need arc cosine. And you don't put this in there. Do not do that. Do not put the fraction that's 80 over 95 into, well, hold up a second. What am I saying here? I said that weird. Do not put this there. That's not right. Put it into the inverse cosine function. In fact, it should look something like this. Oh, try not to steal it. I let it go too soon. There it is. What I want you to do is figure out the angle measure, get your calculator out, go to radian or degree mode, solve for cosine inverse. Cosine inverse helps you find the angle measure. Cosine is the adjacent side divided by the hypotenuse. Thanks for watching.